In this video, I'm going to go through the solution for Java exercise number 4 with you. This is an interesting case studies, a little bit complicated, but if we go through the questions here, we know that what the question wants us to do is just to find the picks in the data set, right? And it has already defined a pick for us, which we are going to go through later on. But if you still can recall, previously we have learned how to find the maximum value given an array. So for example, in this case, if this is an array and we want to find a maximum, we know that 1.5 is the maximum. You should know how to write Java codes to do this by now, where you declare or you initialize maximum as 0, and then you loop through it, you do a comparison, and you update the maximum value as you loop through the array. But what we are given here today is a little bit different, where we need to find the picks. And the definitions of picks has been given here, where it says a reading is considered a pick if it is greater than or equal to its neighboring reading, okay? And for reading at the corners, consider only the adjacent reading, okay? So what we look into here is, right, the first thing is a reading is considered as a pick if it is greater than or equal to its neighboring reading. So for example, now if we look into 1.5 here, we say 1.5 is actually a pick because it is greater than or equal to its neighboring reading, okay? Because 1.5 is greater than 0.7, 1.5 is greater than 0.8. Now we have another pick reading here, which is 1.4, okay? Because 1.4, even though it is not the maximum number within this array, it is still considered as a pick because it is greater than 0.8 and is greater than 0.8 here, okay? So it is greater than both of its neighbor. Now, what happens if we have the corner reading, okay? The one at the corner here, which is 0.0 and 0.8. So for the corner, we just need to consider only one neighbor. So for example, 0.0 here, we just need to compare with 0.3, whereas 0.8, we just need to compare with 1.4. So now let's say, assume that my first reading here is actually 0.5, okay, which is greater than 0.3. So here, 0.5 will be considered as another pick. So there are a few conditions that we need to take note of whenever we are writing the Java codes. So for example, in this case, for the first index here, or the first elements here, we will need to compare the index 0 with index 1, right? Because this is 0 and this is 1. And for the last elements here, we will need to compare the final elements. We know that the final elements in this case will be ECG sample dot length minus 1. This is the last element with 1.4 here. So how can I find the index of 1.4? That will be ECG sample dot length minus 2, right? Okay, so how about the elements in the middles of an array? So for example, now if I want to check whether 0.4 is greater or less than the neighbors, okay, so assume that 0.4 here is I, the index, okay, so I can compare this with I plus 1, which is this, and the left-hand side here is I minus 1, okay, so you will need to understand this concept before we can move on to write the Java codes. Now let's proceed to look into the code which I have written here, because this is quite a lengthy piece of code, so I have write down everything and we're going to go through this. As you can see here, I have declared an array here, which is exactly the same as what I have here. Of course, you can create a scanner object and then you can read the input from the user. That's totally fine. For simplicity, here I'm just going to use back the exactly same array which I have earlier. Next, you notice here I'm using ArrayList, okay, to create another list here. Because if we look into the requirement of the task given, it says we need to return all the peak readings within that array, which means our method, because also here it says we need to use a method, so our method will need to return a list or an array. If you still remember previously, of course, we can create a new array using what we have seen earlier. For example, let's say double, okay, and this is a single dimensional array max list, okay, equal to new double, okay. But in order for us to do this, we will need to specify the length of the array, which, for example, I need to write 5. Okay. The problem now is because we do not know how many maximum reading are there or how many peaks are there within that array. So I will need to use ArrayList double. Okay. Because one of the advantages of using ArrayList here is that we do not need to specify the length. Okay. That's the reason why I choose ArrayList. Now, I'm going to move on to the looping, where we check each of the elements within the array and identify which one is picked. Remember previously we say that, for example, if it's the first element or it's the last elements, we need to use different conditions to check. So this is what I have translated into the Java code. So for example, to check the first elements, I will say I here, of course, I is the index, okay? So if it is the first element, so basically here it says I equal to 0 means if it is the first elements, and if my first element, okay, 0 here, is greater than the second element, which is the only neighbors of the first elements, then I will consider that the first element as the peak. So with that, I will add that first element, which is the maximum or the peak reading, to my max list, okay, which is the array that I have defined earlier specifically to store all the peak reading. Now that's for the first elements, whereas for the last element, if you still remember how we can identify the last element is ECGSample.length minus 1, okay? So if my I, which is the index, is equal to ECGSample.length minus 1, which is the last element, and, okay, I'm using a logical operator here, and the last elements is greater than its neighbor, okay, the only neighbors that the last element has, which we also mentioned earlier, minus 2 here, then I will add that into the max list because that will be considered as a pick as well. So we have done with the first element, do the checking for the first elements, we have done check for the final elements. Now we will need to check all of the elements in between, right? So this is what we need to do here, where we say that if it is not the first elements, if not equal to 0, and also is not the final elements, then we will need to check to the left and to the right, if you still remember. So assume that my index is I, so I will need to check to the left, which is I minus 1, and to the right, which is I plus 1. So assume that my ECG sample I here is, for example, 1.5. Okay, so I will need to check to the left, which is minus 1 here, which is 0.8, and also plus 1, which is 0.7. So if and only if my 1.5 here is greater than 0.8 and greater than 0.7, then only 1.5 here can be considered as a peak. So if it meets the conditions here, then I will add that to my max list. So once I've done all the looping, then I will just print it out here, okay? Print out all the elements that I have stored in max list, because all of these are considered as the peaks. So I'm going to run this, and you'll see that, yes, of course, we will get 1.5 and 1.4 from the data given here, and from the figure that we can see here, these are actually the correct answer. But we're not done yet, because what it says here also is that we need to implement the task of finding peaks using method, okay, with an array as the parameter in your Java programs, which means that I will need to pass this ECG sample, which is an array, to a specific method. As we have said earlier, it will need to return all the peak reading, okay? So here I've created an empty method where the name of the method is generate max list, okay, which is indicates that it's going to generate a list of all the peaks. Now, for the parameter, as you can see here, this is actually an array, okay, which meets the requirement of the task given. But as for the return type here, I specify array list double, okay, because I'm going to return a list of all the peaks reading, and it is in the form of array list, in line with what we have code here, okay? So we all do all the looping, we check on the conditions, and we add that into max list. What is the data structure or data type of this max list is actually array list. That's why we will need to return array list. So you will see for the definitions of our methods, I have array list here. Then I will need to add all the code from the first part here into the method, and then I will need to return an array list. So why do I need to return an array list? Because within my method here, it already indicates that I would need to return an array list, and all the numbers that store within that array list is actually with the data type double. So here I have also provide a combinations of the code with the method, okay? So what you can see here in these sections will be a combinations of the first part and the second part. Just we ignore this one because we do not need to print anything. We just need to return something. So I've copy paste all the codes into the method, as you can see here. And at the end, I return max list, okay, which is with the data type or data structures array list, okay. Now, I have a method here which takes an array as the parameter, and it returns a list of all the peaks reading, right? Now I'm going to run this method to make sure that it works here. So again, I define my ECG sample array here, and I pass this ECG sample to my method. Okay, this is how I call the method. You have seen that already. And this is my argument here, which is an array. So remember that it's not a must that we need to have the same here. Even though here I define it as ECG sample, I can simply change this to X, for example, as long as my array here is X, okay? Well, I just want to show you that it's not a must that the variable within the methods is the same as the variables that we have defined outside the method, okay? Now I pass the array into the method, and of course the method will return max list, and in this case my max list is assigned to my list here, okay? So whatever in the max list will be assigned to a new list here, my list, okay? Now I want to print out again all the peaks reading, so I can just use a for loop here, and print out each of the elements within my list. And note that all the elements within my list will be exactly the same as what we have within max list, right? So if you run this, you will see, of course, 1.5 and 1.4. And if you notice here, the way we loop through an array list is a little bit different compared to the way we loop through an array. So if it's an array, we use mylist.length, and then we loop through it using the index, for example, mylist square bracket j. But if we want to access each of the elements within the array list, we need to use mylist.size. There's a specific method here, and we use another specific method get to get each of the elements within array list given an index. So now, for example, we want to check whether our codes work properly. Now I purposely changed this, for example, this one to 0.5, okay? So if this is 0.5, this will be considered as a peak based on the definitions given earlier, right? What we have seen earlier, it says that for reading at the corner, we just need to consider the one at the left or at the right. And as long as it's greater than or equal, then we will consider that as a peak. So in this case, my 0.5 here, okay, even though it's not the maximum, but because it is greater than its only neighbor, 0.3, then my 0.5 here should be considered as a peak. So now I have changed this. Let's run this and check. So as you can see, we get the peaks reading 0.5 as well. So I think that's it for the solutions for Java exercise number 4. Thank you very much.